Hello, let's continue our Sudoku adventure with staples by Gene. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these region sum lines in the grid. The way these work is every time they cross a box border, they become a new segment. So this is a segment, we cross a box border, this is a segment. Now we cross a box border, this is a third segment. These are not the same segment. We have a segment here, and a segment here. And the sum of each segment is the same as long as they're on the same line. So whatever this sums to, it's the same as these two, it's the same as these two. This is also a segment on a line, but it's a different line, so it can have a different sum than these three. But it would have the same sum as these two and this guy. All right, so that is region sum lines. We also have Krupke doots. These are these elongated dots here. One might call them ellipses, or actually they're kind of rounded. They're capsules. I think that's the exact shape, a capsule. Anyway, doots are straight lines between pairs of cells. Indeed. A white doot separates two pairs of cells whose respective sums are consecutive. So whatever these two green sum to, it's going to be consecutive with what the purple sums to. So say this was 2, 3, green sums to 5. The purple could sum to 4, say with 1, 3 like that. Or it could sum to 6, say with 2, 4 like that. Or 1, 5. Anyway, so we know they're consecutive. We don't know the order. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. My immediate thought is how this doot interacts with these segments. Because we know that whatever these add to, these two green cells, whatever they add to, it's the same as what purple adds to. But we also know that the green cells and these two cells of the purple are consecutive with each other. So let's just give an example. Say this summed to 5. That would mean that, oh, sorry, I guess 5 doesn't work. Say this summed to 10. If this summed to 10, then this also sums to 10, which means this has to sum to less than 10, but it also has to be consecutive with 10, so it would sum to 9. And so the result is this is always a 1 because it has to make up the difference between these two, which are consecutive. The other thing that we know is that this and this add to the same thing as each other, whatever it is. And so whatever this is, we'll call it x. The sum of all of these cells is 2x, which means it's even. But we know that the sum of the entirety of the box is odd, because 1 to 6 adds to 21, which is odd. Which means if this is even, this has to be an odd digit in order to make that up. And so that gives us two options for our sum. Because our sum is either 21 minus 3 or 21 minus 5 divided by 2. So 21 minus 3 is going to be 18, making our sum 9. Or 21 minus 5 is going to be 16, making our sum 8. So we sum to 8 or 9. Now, if we summed to let's start with 9. If we sum to 9, then this could be 4, 5, or 3, 6. So not a 2 on it, I suppose. If we sum to 8, we'd be either 2, 6, or we would not be 3, 5. It would be 2, 6 only. This would be 2, 6. Sorry, if this was a 3. No, sorry, if this was a 5, this would be 2, 6. And this would be 3, 4. And that would all work out. Okay, so I don't know exactly what this adds to yet, but maybe this marking's enough. And then this adds to the same thing. With a doot here. These two add to the same thing as each other. Well, I can tell you, okay, one thing I can tell you is that we need a 1 up here somewhere, but it's not going to be here. Because if the 1 was here, then this digit would have to equal, the sum here would have to equal either 8 or 9, which would make this a 7 or an 8. That's not going to work. So the 1's over here. I don't think that's super helpful, but who knows? So neither of these are 1, so it doesn't really matter. Maybe it has to do with this guy, because this is a segment on its own. If I were to color this, whatever green is the sum of these and these. So our sum is anywhere from 3 to 6. The other thing we know is we know the parity of the sum, because these are consecutive sums. So these 4 cells are going to sum to an odd number, because one of these sums will be even and the other will be odd. That's just how consecutive numbers work. One will be even, one will be odd. And so this will sum to an odd number. And so in order for the whole box to sum to an odd number, these have to be an even number, leaving only 4 and 6. Now, how do we sum to 4? Well, only 1, 3, and the 1 is already used. So actually we sum to 6. And we aren't 1, 5, so we are 2, 4. And then now this can't be 2, 4 because of the 2, 4 pair. So this has to be the 5, and this is the 1. There we go. That's quite nice. And that gives us the 3 here, meaning our sum is 9. This sum is 9. And so remember, we can't do 3, 6. So we have to do 4, 5. This can't be 4, 5, so it has to be 3, 6. It's the only way to add to 9 is 3, 6 or 4, 5. Now these add to, these are just the other two digits, 2, 6, which do add to 8. So that's 2 and 6. Very nice. This is working out. What are these digits left? Because I bet we can do the doot. We need a 1. We need a 3 and a 5. That's not 1. This is 3, 4 only. So, I mean, I get the feeling this has to be a 1. That would make this 3, 5, and that would make this 7. That would work. If I try to make this a 3, this would add to 9, and then this would be 1, 5, which adds to 6. Yeah, I think our only option is this is a 1, and then we have a 3, 5 pair here. All right, so we know that this is either going to be 2, 3, 5, or 3, 4, 5, but we know it's got a 3 and a 5 down here. It's a 3, 5 pair. We know 1 and 6 are up here. But the important thing to note is that this does not have a 5, so we are going to be adding in different ways. I was thinking maybe these were the same digits as these, but they are not, because we know there's a 5 up here, and we know there's not a 5 down here. I bet there's more Sudoku I can do, and I bet this doot might be helpful. I get the feeling this can't be a 1, because if this adds to 4, yeah, if this was a 1, this would add to, oh, sorry, I forgot that it was consecutive, sorry. If this had to 4, this definitely couldn't add to 3, because this can't be 1 or 2. Could it add to 5? Yeah, so if we just fill this out, this is 4, 5. So we could do a 4 with a 1 here. Oh no, but then, but if this added to 4, this would already be a 1. Look, this would be a 1. And so now this would need to, this definitely isn't going to add to 3. Look at that, 4, 5. Could it add to 5? This would be 4, and this would be 1, but that would repeat the 1. So actually this cannot be a 1. And this is a hidden 1, 6 pair. Now, if this was a 6, our minimum would be 10, which would make this a minimum 7. So this cannot be 6. This is 1 and 6. Places the 1 there. Places the 1 here. We're done with 1s. This is now 2 or 4. So we're either adding to 5 or 7. Whether we're 5 or 7, this has to add to an even number, because this adds to an odd number. And so an even number would require this to be odd. So this is 1, 5. And actually, this being 6, this could be 5 or 7, so it doesn't matter how that resolves. This is a 2, at least not to the doot. We're getting there. Sorry, that sneeze was coming. The 6s place the 6 in this box, and then the 6 is placed here. All right. This region sum probably just resolves some deadly pattern that we're going to get from doing a lot of Sudoku. This is 2, 3, 4. This is 2, 4, 5. We can actually place the 5 in the column. This is a 3, 4 pair. And that does make a 3, 4 pair in this row, making this 2. This is 2, 3 only, not a 4. That's a 2, 3, 4 triple. We need a 5 in the box, which goes there. And this is 2, 3, 4, not a 4. Okay, so how does this resolve? Well, this is basically a doot, because we have a 5 here and a 6 here. So the sum of these needs to be 1 less than the sum of these. So if this was 3, that would end up 4. That would end up 7. And this would be 2 and 4, and that would end up 6. That would be okay. If this was a 2, this would end up 3. Gosh, is there no way to resolve this cleanly? Okay, there's got to be a clean way to think. I mean, the 3 works. So the question is whether the rest of the puzzle resolves that way. It might. I think it would. Okay, so one little trick we can think about here is if we completely ignore any of our variant rules, we only have by values left. By values being cells that have 2 options. We only have by value cells left in the grid. And so there are at least 2 solutions. And I think they're all connected just at a glance. They seem to be all connected. So there's going to be 2 solutions. And so I saw 3, 4 work. So 3, 4 is going to work. So we just got to prove that 2, 3 doesn't Or sorry, that 2 doesn't work here. So 2 puts a 4 here, which puts a 3 here. That would add to 5. And remember, this needs to add to 1 less than that. So this would have to add to 4, and there's no way to add to 4. 2 doesn't work. So this has to be a 3, and that's going to resolve the rest of the puzzle just automatically. There were 2 solutions left. Cool. Alrighty. Well, that was a cool puzzle, Gene. As always, love your puzzles. They always have a nice bit of complexity to them, but they're not like overwhelmingly difficult. They're still approachable. All right. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.